Energetic X Morning Pulse, Nuclear Fuel Special Edition, December 12th, 2025. Topic of the day: Nuclear fuel, types, reserves, production, and the road to the SMR economy. Good morning. Today's specialized briefing covers the global nuclear fuel landscape, from uranium and thorium to HALEU and TRISO. As SMR programs accelerate worldwide, fuel availability is rapidly becoming a central pillar of the new energy economy. 1. Global uranium demand: 68,922 in 2025, set to double by 2040 according to the WNA World Nuclear Fuel Report 2025 to 2040. Global uranium demand in 2025 is estimated at 68,922. WNA scenarios. Reference scenario: 150,002 by 2040, upper scenario: 204,002. Drivers of the surge: China's expansion, SMR fleets in Canada, the US, Poland, and the UAE. Growth of Gen 4 technologies. Current primary production covers 90% of demand. By the 2030s, 10 to 12 new uranium mines will be required globally. 2. Uranium reserves: 12.4 million tons, anchored by Australia and Kazakhstan. OECD NEA and IA Uranium 2024 estimates global identified uranium resources at 12.4 million tons, of which 3.2 million tons are economically recoverable. Top 5 uranium holders: Australia, 3.6 million tons; Kazakhstan, 2.9 million tons; Canada, 1.7 million tons; Russia, 1.2 million tons; Namibia, 1.0 million tons. He 2025 insights: the U.S. holds only 28,000 tons of inventory, equal to 14 months of reactor operations. China maintains 12 years of strategic reserves, altering geopolitical risk dynamics. IAEA notes: access to raw material is becoming as strategic as access to reactor technology. 3. Uranium production: 55,000 to 57,000 kilotons in 2025. Kazakhstan dominates global uranium production in 2025, is projected at 55,000 to 57,002. Country breakdown: Kazakhstan, 22,400 t; Canada, 7,200 t; Namibia, 5,610 t; Australia, 4,550 t; Russia, 3,300 to 3,400 t; Uzbekistan, 4,000 t, strengthening its position as a rising supplier. The United States produces less than 200 t/year, but is rebuilding its entire fuel cycle. The DOE is allocating 3.4 billion US dollars to restore domestic mining, conversion, and enrichment capacities, including HALEU. Core objective: reduce dependence on Russian enrichment services. 4. HALEU, the strategic fuel for SMRs: 900 kilograms produced, 350 tons per year. Planned HALEU is essential for SMRs such as Natrium, say, 100 and BWX, 300, as well as for Gen 4 reactors. Key developments: Centrus Energy delivered 900 kilograms of HALEU, completing Phase 2, the first meaningful U.S. production in 70 years. DOE extended the program through 2026, with options into 2025 to 2034. Nusano announced plans for 350 tons per year production capacity by 2029. Before 2024, no commercial-scale HALEU production existed. The supply gap remains critical. SMR demand by 2035: 50 to 70 tons per year. Current global production: less than 1 ton per year. 5. Thorium, the new oil of nuclear energy. China and India take the lead. Thorium occurs 3 to 4 times more abundantly than uranium. Global reserves: 6.4 to 14.6 million tons. Top holders: India, 846,000 t; Brazil, 632,000 t; Australia/USA, 595,000 t each; China, plus 1 million t. Technology leadership: China operates the TMSR LF1 molten salt test reactor and targets a 10-megawatt demonstrator by 2030. India's 3-stage thorium cycle aims for 100 gigawatts of thorium-based nuclear capacity by 2047. 6. TRISO, the unmeltable fuel for HDGRs and SMRs. 40,000 compacts delivered for Project Pele. TRISO fuel withstands up to 1,800 degrees Celsius without melting, making it ideal for HDGRs, pebble bed reactors, mobile microreactors. Market overview: 2024 value 382 million US dollars, 2033 projection 554 million US dollars, global production less than 2 tons heavy metal per year, but rapidly expanding. Recent milestones: BWXT delivered 40,000 TRISO compacts to INL for Project Pele. X Energy will produce 5 tons per year by 2026 for the SE 100 fleet. Standard Nuclear plus Framatome target 2 tons per year from 2027. Duke Energy secured TRISO supply for the 2030s. Cons: high cost, substantial graphite waste. Pros: extreme safety ideal for AI data centers, Arctic facilities, and defense applications. 7. Geopolitical risks. Nuclear fuel becomes a national security asset. 3 structural risks defined 2025. 1. Enrichment and conversion bottlenecks. 70% of capacity is concentrated in Russia, China, and the EU. The US is accelerating large-scale substitution programs. 2. Rising military demand. TRISO and HALEU increasingly fall under dual-use classifications. 3. Supply chain redesign for SMRs. SMRs require new fuel forms. Legacy supply chains are insufficient. 8. Why this matters for Energetic-X and IMPC1. A forming fuel deficit creates opportunity for Energetic-X modular systems clients now face. SMR constraints. HALEU/TRISO shortages. Solar/BESS limits intermittency. IMPC plus Stirling 24/7 hybrid thermal autonomy. 2. TRISO-based systems integrate naturally with IMPC, heat extraction, hydrogen pathways, thermal storage. 3. Energetic-X can launch a nuclear fuel and SMR intelligence analytics division, a strategic differentiator ahead of WFES 2026. Comparative summary table: fuel type, global reserves, production/demand, key countries/notes. Uranium 12.4 million tons, 68,920 t. Australia. Kazakhstan. HALEU 900 kilograms, ramp to 350 tons per year. Centrus. Nisano. Thorium 6.4 to 14.6 million tons minimal. India. China. MLEX 200 to 300 tons per year. France. Japan. TRISO U/HALEU based less than 2 tons HM per year. BWXT. X Energy. China. Key takeaways: 1. The uranium market is entering a controlled deficit by the 2030s. 2. HALEU is emerging as the critical fuel of the 21st century. 3. TRISO is the core enabler for next-generation microreactors, military use, and AI data centers. 4. Thorium provides a strategic reserve for the 2030 to 2040 horizon. 5. Massive new production capacity will be required, a significant opportunity for Energetic-X.